Welcome, Algebra 2 students. We're in lesson 59. We're going to talk about some experimental data. Linear equations in two unknowns have applications in real-life problems. In chemistry and other advanced courses that use math, we find that the relationship between two variables is often expressed by a linear equation. Fortunately, many of these equations and their graphs are straight lines, thus linear equations. We can look at the graphs and get a pictorial representation of the relationship between the two variables. Lab experiments are used to confirm these theories. If theories indicate that a relationship is linear, we estimate the line indicated by the data points. Then we write the equation using the variables of the data rather than x and y. So we sub in the names of the variables instead of just using x and y coordinates. It's whatever is on this side versus whatever is on this side. So for instance, in this chart that we have here, this side is bronze. I'm going to see if I can write bronze sideways. I may not be able to. Barely. Okay, so that's bronze, right? And this side is copper. And both of these are in kilograms. So this is what our chart represents, is the relationship between bronze and copper in kilograms and how they did in this experiment. So this graph came from an experiment involving the bronze and the copper, and the shading around the points indicates that due to potential errors in the measurement, the data may not be exact. So they have like an error, a margin of error, plus or minus all the way around the point on the chart. The line represented by the data points has been estimated. So what they did was they found a point on the line and they drew it, and they tried to make a straight line as much as possible with the information. So they drew a straight line through the middle of their data to try to estimate and create a linear equation. Note that these two scales are different. For every 2 units here, we're in units of 5, and every 2 blocks here, we're in units of 10. All right, so how do we turn this into a linear equation that represents our bronze and our copper? So first, the bronze is graphed vertically and the copper is graphed horizontally, so that the equation we will replace the y with bronze and the x with copper. So that means B for bronze equals the slope, and the the periodic symbol for copper is Cu. The slope of Cu plus B, right? We recognize that as y equals mx plus b. We're replacing the y with bronze and the x with copper. That's all we're doing, and it's the same formula. So from the triangle, we see we have a slope of 3.5, right? We have 35 up and down, the y, and 10 on the x. So that's 35 over 10. And when we divide, that becomes 3.5. So it becomes B equals 3.5 Cu plus B. So now we're going to solve for B. We're going to find a point. And in this case, the point that we have for sure is 15 and 40. So we sub in 15 for the copper and 40 for the bronze. So 40 is equal to 3.5 times 15 plus B. So when we calculate that, we get that 40 is equal to 52.5 plus B. When we complete the math, we subtract 52.5 to both sides, we get 12.5 negative is equal to B. So now we could take this negative 12.5 and put it in for B, and we get that B is equal to, bronze is equal to 3.5 times the copper minus 12.5. And that would all be in kilograms. This equation only approximates the equation of the line indicated by the data points. The values of m and b we found are not exact. They're close, but they're not exact. All right, let's do another equation. 59.2. I'm going to clear this, and I'm going to draw us another little chart that we can kind of do. So we have here, I'm just going to write at the top because it's better. You can actually read it. On this side, we have nitrogen, and it is in grams, and that's G. And nitrogen is written as N, so N in G, okay? And our scale is 10, 8, 6, 4, 2, and obviously this is 0, so I'm going to draw my line. And then we have 10, 20, 30, 40, 50. And I'm going to draw my line. All right. So now let's put in our points. We have a point right about here. All right, I'm going to pause and do the graph because this is going to take a while. Okay, that took a hot second. But now we have our data has been put in, and we've drawn a line through the middle of our data. So now we're going to measure the slope. So we're going to come from this point where the line crosses here, and we're going to go up to this point, which is about halfway on this line right here. So let's draw our little slope line. Right, just like that. All right, so this is going to be right about, this is 7, so this is about 7.5 right here. But this is, all right, starts at the 1, and this is not quite half, so we're going to call this 6.4. And then this from here to here is 35 units. All right, so now what is on the bottom? This is sulfur. I forgot to put that. This is sulfur, and it's in grams. And it is written as an S in grams. Okay? So now we need to write our equation of the line. We have the y-axis is nitrogen, so that goes where the y goes. And then we have our slope, and then the x-axis is sulfur, and then we have our plus b, right? So now we have our y is 6.4. So our slope is going to be 6.4 over 35, or divided by 35. So we'll just use our calculator. And we'll calculate 6.4 divided by 35. 0.18. That's what we'll round it down to, is 0.18. Right? So that's what we'll put it in. We'll say that nitrogen is equal to 0.18 sulfur plus B. And we have our point right here. We have a point 1 and 10. So it's 10 on the x-axis and 1 on the y-axis. So this is 10, 1. So we're going to use that to sub in for our x and y. So nitrogen is 1 and sulfur is 10. So 1 is equal to 0.18 times 10 plus B. I'm going to move this right here, this calculation. I'm going to move it over just a little bit. There we go. So I can continue here. 1 is equal to 1.8 plus b. And when I subtract 1.8 from both sides, I get a negative 0.8 is equal to b. So now we can rewrite this, and we could say n is equal to 0.18 sulfur minus 0.8. And that is going to be in grams. All right, so we see how that works. All we're doing is just using our y equals mx plus b, and whatever y is, whatever this y-axis is, in this case it was n, we're subbing that in. And whatever the x-axis is, we're subbing that in. It's the same thing we've been doing, we're just turning an approximation into a linear equation. That's all it is. So you guys could do this. It's all about just drawing the line and estimating as best you can. So let's move on to simultaneous equations with fractions and decimals. Some systems of simultaneous equations that contain fractions and decimals look very complicated. But if we remember, as the first step to change these to equations in which all the numbers are integers, the solution will be a whole lot easier. So let's try one of those. So starting off, we have 59.3. And we have the first equation is x over 2 plus 3y over 5, that's a 3, equals negative 2 over 5. The other equation in this system is 0.06x minus 0.2y equals 1.04. All right, so first we need to get rid of the denominator in this one. We need to make this a whole number, and because it's an equation, we can take what would be the common denominator of 10 and multiply each one to resolve it. So let's do this one first. So if I take 10 and multiply it times x over 2, the factors 2 and 5, 2 cancel, so this is going to be 5x. Now if I do the same thing to this 3y, I say 3y over 5. The 5 out of here cancels, so this is 2 times 3y, so it becomes plus 6y. Okay? If I do the same thing to this final bit and say 10 times negative 2 over 5, the 5 cancels and this becomes a negative 4. All right, so now we have a new equation for this one. We can write it down here. I forgot to put my little thing right there. So now we have 5x plus 6y equals 4. All right. We want to keep going. Sorry, I need a piece of paper. Here we go. Now we're going to do the same thing down here, only instead of multiplying to get rid of the denominator, we're going to multiply to get rid of the decimal. So in this case, the biggest decimal place is the hundredths, so we're going to multiply everything by 100. So 100 times everything here. All right, so that's going to be, move this 2 decimal places back. That's going to be 6x minus 20y equals 2 places, 104. So we can just take that and write it over here. 6x minus 20y equals 104. And this is supposed to be a 4. All right. Now we have some numbers that we could actually work with. So what we want to do is figure out how we want to solve them. Do we want to use elimination or do we want to use substitution? Right? So I think the easiest thing is going to be to cross multiply the 5x and the 6x, because otherwise we're going to have a really huge number if we multiply to get the variables here to match up. So let's do -6 here and +5 here. So that would be -30x. 6 times 6 is a positive, oh wait, we're doing -6. So it'd be a -36y. And -6 times 4 is -24. All right, now we're going to use 5 down here. That's going to be 30x minus 100y equals 520. And when we draw our line, we see that this is going to be, oh wait, sorry. This was already negative because of the -2. I just didn't bring it down. I forgot to do that there, right there. See? So it's negative. So this -5 times -4 will be a +20. So I made a mistake there. So check your work whenever you do that. Sometimes that's going to make the difference when getting it wrong and right. So that's going to be 540. This is going to be -136y. And these are going to cancel. So when we divide both sides by -136, y is equal to -4. Now we could sub y in here, and we see that 5x plus 6 times the -4 is equal to -4. 5x minus 24 is equal to -4. We add 24 to both sides. We get that 5x is equal to 20. And x is then going to be equal to a +4. So our solution is 4, -4. All right. So that's really what this part of this lesson is talking about, when you have these in weird formats, just put them into, transfer them into what you know you can do to put them into whole numbers with the variables. Turn them into whole coefficients, whether they're decimals, whether they're fractions. Just do the multiplication required so that you can then solve it more effectively. All right. Don't let that throw you for a loop. This is an opportunity for us to show you that now, so when you see it later, you go, oh, I know what to do to get to where I can solve it. All right, so now we're going to talk about from rectangular form to polar form on a graph. So I'm going to have to go back down here to my graph. Let me clear this page so we can use it. And give me just a second. Let me set this up. All right, here we go. Here's our setup. Now this is the y-axis right here, and this is the x-axis right here. So don't want that to confuse you. Let me put this online so you could see it a little bit easier, so that it's squared up, so you can read the points a lot better. All right, here we go. That's going to be a lot easier. All right. So I wanted that point to be where it's supposed to be, basically. So let's look first. We have -5r. So to the right, it's -5 to the right. So the negative means go to the left. So 1, 2, 3, 4, 5. So -5 on the x-axis, and -3 up would be down. So 3 down. 1, 2, 3. So it's -3 right there. So that's our point, -5, -3, if we were to use the xy coordinate. All right, we begin by locating the point on the coordinate plane and then drawing the triangle. So here's the triangle. Right there. This is the full triangle. I'm going to go ahead and draw this. And there we go. That's our full triangle. We remember that -5 means 5 to the left, and -3u means 3 down, which we just talked about. First, we find the tangent of angle, I think this is called omega, maybe. I'm not sure. Whatever it is, this is a symbol for this angle. Just call it it's like a variable. It's just a symbol to represent this location. So we're going to find the tangent of this because we don't have the degree of measure. That's what we're looking for. And we know that tangent of this, right, this symbol, whatever that is going to equal the opposite over the adjacent. That's TOA, right? So the opposite is going to be this, 1, 2, 3. So the tan here is 3, and we have 1, 2, 3, 4, 5 for the adjacent, because this is the adjacent side right here of the right triangle, right? So when we do the math, let's bring up our calculator. We get that 3 divided by 5 is equal to this, and that the inverse tan of this is going to be 30.96, which we can just round up to 31. So our degree of measure here is 31 degrees for this. So O equals 31 degrees. Now we can use either the sine of 31 or the cosine to find H, which is the hypotenuse. So let's do the sine of 31, right? Because so is opposite over hypotenuse. And the opposite, like here's our 31 now, the opposite is 3, and the adjacent is 5. So the opposite is going to be 3, so the sine of 31 degrees is equal to 3 over the hypotenuse. We don't know what the hypotenuse is. So let's find the sine of 31. So 31, and we go back to the original sine. So that's 0.52 is what that looks like to me. Or we could say 0.515. Let's just say 0.515. So 0.515 is equal to 3 over H, right? We know we can flip that and say that H is equal to 3 over 0.515. And we can do the math there. And that gives us H is equal to 5.83. All right, so 3 divided by 0.515. 5.83. This rounds up to 5.83. Okay. Now, you might be wondering, how in the world did I do that? How does that work? Okay, so here's how we do that. Here's how we flip it, right? Let me show you up here. If you have 0.515, and that equals 3 divided by H. We know that we can multiply both sides by H, right? These would cancel out and we'd be left with H times 0.515 equals 3. Well, now we can divide both sides because it's a factor by 0.515, and then this would cancel out. So h would then be equal to 3 divided by 0.515. So that's what we did just by flipping that around, okay? We just skipped a couple steps. So know when you have this that you can, in your head, you can go, okay, multiply both sides. That means h times this is equal to this, because it's the inverse operation, which means you can divide this by this, and that'll put h by itself, just like we did over here. All right, that's just a simpler way to do it. You're just skipping these 3 lines by just moving this here and moving this here. All right. Where did I leave off? Okay, so because the measurement starts here at the x-axis, we have gone all the way around. So we know we are greater than 180 right now, right? So we take this location, this vector, this negative 5r minus 3u, and we set it equal to the vector, or the point length, which is 5.83. And then we put in, we have the 180 already, plus the 31. That's going to be 211 degrees. And that's how we would write that. So we had to find this length of the hypotenuse, which is 5.83. That's our vector length. And then the direction. And the direction is clockwise. So we start here, we go 180 plus 31. So that's how we do that. All right. Fun stuff, right? Maybe not. All right. Anyway, if we used Pythagoras' theorem, we could also come up with a number here. We could have used 3 and 5, and we could have said 3 squared plus 5 squared equals h squared. That would have been 9 plus 25 equals h squared. So that would have been, what is that, 34 equals h squared. We would have said the square root of 34 equals h. And so we would have written it like square root of 34, 211 degrees. So if you use the sign method, you get a more exact, you get a decimal. If we do the Pythagoras theorem's method to get the length of the hypotenuse, then we get a square root here. Now, I'm willing to bet square root of 34, 34 square root, same number, right? Same number. So it's just as exact. So if you want the decimal, you could do it like this with Pythagoras theorem and then just plug it in to your calculator and you'll get the same answer. All right, that is all we have for lesson 59, from rectangular form to polar form, and about the transferring those weird setups into a system of equations that we can solve, and also about turning data into a linear equation. If you have any questions about those, please feel free to message me, and I will see you guys in lesson 60.